probably one of the key benefits of Benny devices is it accelerates your development time, and you can be sure that what you get is going to fit in the enclosure. So that's really good stuff. Hello everyone, this is our second Ask an IP Expert segment with IP Exchange. We're at the IP Exchange studios. I'm here with Petr Dvorak from Benny Devices. So I met Petr on LinkedIn a lot when I first joined IP Exchange about a year ago. And then we met in person at Electronica. And I thought he had some great ideas to do with hardware. So we've got him on here to talk about considerations you should make when in terms of hardware design and enclosures. So Petr, to begin with, I think probably the best thing to do is just tell a little bit about yourself and what Benny Devices does.
Mm-hmm. Yeah, thank you, Ivan. Thank you for the very nice introduction. Thank you for having me. It's such an honor to me to be guest in your podcast, because it's not normal to be invited to a podcast, and I'm really honored. So thank you for having me.
No worries.
Okay, so here is a short slide deck about the Benny devices. Mm-hmm. I called the introduction the efficiency of hardware design templates, because I think the hardware design templates can make your development process more efficient. I will say later how. So normally, I as I work for a living, I'm working as a freelancing hardware design engineer for like almost 6 years now, and I provide hardware design services to customers from the entire world. And about half year ago, not about 1 year ago, I realized that there is something missing on the market with hardware design services. I'm like hardware design engineer for 20 years since my graduation at the university, but I always struggle with mechanical design. To be honest, I don't do anything mechanical. I always struggle with the mechanical drawings, everything, and every time I started with a new enclosure or new anything, I made many mistakes, like mounting holes, diameters, mounting hole positions, PCB shape, PCB size, everything. Even I double checked everything, triple checked everything. I always made mistakes. And 1 year ago, I realized that when I struggle with such a mistake, such as issues, many other engineers similar to me struggle with the same thing. So I realized that there is a place on the market to offer the hardware design templates. And what's hardware design templates? It's what's the problems and solutions that lead to the hardware design templates. Yeah, as I say, I always struggle with mechanical drawings, mechanical design, and I'm pretty sure I'm good at capturing the schematics and the PCB layout and soldering and making the device, like powering up the device and everything. But the common problem, I think, for many engineers is that they put the enclosure design to the end of the process. Okay. Because we know how to capture schematics and how to prepare symbol libraries, footprint libraries, everything. But the enclosure design is something that we put to the very end of the process, because we don't enjoy the designing, and I don't know, sometimes don't want to ask for help to the mechanical engineers and constructors and everything. So we put the mechanical design to the end of the process, because we are not mechanical engineers. Yeah, naturally. Solution, I think we have to reverse the flow. We have to start with the enclosure, and to choose the nicest, then the most, the beautiful enclosure for our design. Because when the design is to be nice and like eye-catching, the enclosure must be must be fine. So on the picture on the right side, there is a typical example of the common do-it-yourself design. Yeah, some carrying PCB, carrying a few PCB modules, and the design is 3D printed later at the end. So yeah, it looks quite good, but nothing special. Yeah. So I realized that we need to choose from the library of enclosures. Ideally, download the PCB layout with the bare PCB with verified shape, size, mounting holes, everything. Yeah, the problem is solved with, as I said, the verified PCB, because once we choose the PCB for the first time, the never before used enclosure, we need to go through the entire mechanical drawings. And I want to
Yeah.
make the engineer's life easier, because yeah, you can see on the example drawing, there is a quite simple mechanical drawing of the BC enclosure by Phoenix Contact, and you can see on the picture there are so many details on the so many diameters, so many positions, so many details, and you need to understand the drawing. You need to know how to transform it to for your CAD. Even if you can download the DXF or the, I don't know, the CAD formats, you must know how to use it, how to handle it. So you can go to the Benny devices. You can see, yeah, the portfolio and the Benny devices is not so vast, not so wide, quite narrow still, but I'm working on it. So you can download the schematic, the template for you, and I did the heavy lifting for you.
Nice.
So
I remember when we talked at Electronica, you mentioned, I'm not going to name companies, but you went around to some companies, saw their enclosures, and there was like nothing telling you about it was like kind of, it's this many inches by this many inches, but it didn't tell you anything about the inside structure. And I remember you being rather frustrated.
Yeah, exactly. There are, like, I see two worlds, like mechanical engineering world and electrical engineering world. And sometimes there is no overlap between these two worlds, between some companies, and sometimes companies don't understand the needs of the electrical engineers, that we are not proficient with mechanical drawings and the designing. Yeah, they say you can download the 3D model of the enclosure and design everything, but we don't know how to do it. We are electrical engineers. We use KiCad, we use Eagle, we use I don't know, Altium Designer, but we are not constructors of the enclosures and 3D modelers. So this is how there is a hardware design template. Connectors, yeah, another area. Yeah, you can see the BC.
I think I remember you doing a post a while back about some problems with connectors where you don't, like, their minimum clearance and all that kind of stuff, because some connectors it's not a case of you can put them wherever you want. And I've definitely had this problem before when building stuff. So I'll like put a connector in, and then I find out that I'm actually shorting the end of a jack on a pot that's inside the box, which is awful. But thankfully, I'm not a professional electronics design engineer, so
yeah, you can be pretty clear that and pretty sure that we all do the same mistakes, and we struggle with the connector solution. The fact is that there is the entire universe of connectors. Let's say the screw terminals you can see on the picture. There are like hundreds brands, hundreds companies from the US, from Europe, from Asia, everyone, and there are slight differences, but not every screw terminal fits in the enclosure as it can see on the picture. So when there is an enclosure and there is a need for connectors, I pre-selected the the connector brands, the well supported connectors by renowned companies with well market available connectors. And a part of the hardware design template is the bill of material with these important components: connectors, screw terminals, USB connectors, Ethernet connectors, pin headers, everything. Because speaking of pin headers, there are like, I don't know how many, like a million different sockets and pin headers that differ in size, height, thickness, everything. So once you need to design multiple board to design, you are lost in selection of such a component. So I tried to make engineers' life easier by pre-selecting, and it's only a recommendation. Everyone can use different terminal, different connectors, but the ones I recommended are verified and they work in the enclosure.
Cool, nice. So just to clarify, what does Benny Devices offer? Are you operating the enclosures themselves, or it's kind of?
Yeah. This is thank you for the question, Ivan.
Yeah.
This is a very good question, because sometimes I think I fail with presenting the Benny Devices. I don't sell enclosures. I only offer the digital content, only the project for your ECAD, primarily KiCad, on a secondary Altium Designer. So you can buy the digital project for your ECAD, not the enclosure. The part of the hardware design template is, as I said, bill of material, not only terminals, but as well the links to the distributors of the enclosures. You can buy everywhere. You can buy directly at the manufacturers. You can buy at the DigiKey, Mouser, everywhere, anywhere you want. But I provide you with the digital data, so not enclosures.
Yeah.
You can download templates, not to receive it in a box.
Cool. So, in summary, if someone wants to use a certain enclosure, you have done all the hard work so that they can use it, and you've let them know what connectors you think will work best for working with that enclosure. With that,
yeah.
Okay, cool.
Exactly.
Nice.
Exactly. So this is, I wanted to show like 4-step way of using the hardware design templates.
Okay.
Let's say you want to design a small IoT sensor device, with the Bluetooth communication module. So first step is choosing the right template. You can visit, or you go to the Benny Devices, and you let's say chose the enclosure with the round shape as it's in a step 1. The step 2 is the schematic creation, schematic capture. It's common for all projects, but as you can see, back to the step 1 picture, there is an example of the PCB. So part of the template is digital data for your PCB editing software like KiCad, Altium Designer. So once you have the schematic finished, you directly open the PCB layout, and there is like waiting the PCB for you to be like accommodated with the components and everything.
Cool. And I can see that all the screw holes are in place so that it'll fit exactly into the
you can be pretty sure that we can make many mistakes, like component values, in circuits, interconnection, everything. But you can be pretty sure that there is no mistake in mechanical design of the PCB. Mounting holes are on their place. Diameters are correct. PCB shape is correct. Everything is fine. Everything mechanical is fine. So at least a few mistakes less in the design process.
Nice.
So you finish the PCB layout, you can manufacture the device and then mount it in the PC in the enclosure, and you are done. This is the typical process.
Cool.
So yeah, in the portfolio I made a few screenshots from the Benny devices.
Nice.
Yeah, everyone can visit Benny-devices.eu, but these are the examples. So I want to present or want to offer the multiple families of enclosures, like for industrial devices, for IoT devices, for home automation, for small devices like USB keys and like small sensor, small nodes. So some enclosures for DIN rail, the round enclosures by multiple mainly European manufacturers, but from the US as well. So you can see, the one thing I started to offer is as well the schematic hardware design. This is I think it's not really good to mention it here, because I have spoken about the hardware design only, like PCB layout, PCB shapes, but I started to offer the schematic templates as well, because like I think one or two pieces only at the moment, but I realized that some engineers struggle with the fresh start with the new, for example, microcontroller. So I prepared the minimal schematic for the microcontroller core. So
cool. Okay.
So I don't know what to say more. Yes, USB key size, multiple key size, art case by OKW company.
Okay, nice.
Yeah.
So who are your enclosure company partners?
Yeah, I cooperate closely with Hammond Manufacturing.
Nice, one of my favorites.
Yeah, my favorite as well. The support from the headquarters and from the company management is perfect. I can recommend. Yeah, they are like very supportive for engineers like me. Camden Boss from the UK.
Okay.
Italtronic from Italy. As I said, OKW from Germany. And I think Phoenix Contact, the BC enclosures from Germany. So Phoenix Contact from Germany. I'm going to release the bigger version next week, like the big version
nice.
of BC industrial enclosure. This is the 53 millimeter wide, and I'm going to release the 107 millimeter wide, so twice as big. So yeah, speaking of the BC enclosure, it's quite interesting enclosure, because there are multiple options how to stack the boards. You can stack them in parallel, vertical, and multiple choices you have, and I think your design can be quite interesting. Not interesting. You can reach, and you can even solve a few design issues with using the different board positions, because once you need to use, for example, LEDs or buttons, you can choose one position, a particular position of the board, and place the LEDs or buttons on the top of it, and you are done with it. You don't need to use cabling and anything. So this is it. So this is basically everything about Benny devices.
Cool. So just out of curiosity, how many hardware templates have you got at the moment? Roundabout.
I think currently we have like 20 hardware design templates at the moment. At the beginning I wanted to release one hardware design every other week.
Wow.
It was it was quite challenging, and I have to admit that I don't keep the track with the plan. But
Yeah.
but I'm trying to release at least one new hardware design a month. So yeah.
I guess that puts it into perspective how much effort actually goes into trying to make sure that you can fit your PCB into an enclosure.
Yeah, quite big effort with designing, and as I said, every PCB is verified, so I need to order the PCB manufacturing and to test it in the enclosure, to make photos, because I need my customers to be 100% sure that
Yeah,
they are
of course.
always verified and proven. So yeah, I want only perfect enclosure, perfect PCBs.
Nice.
One of the hashtags I'm trying to promote with the Benny devices is like no waste design, because as I said, we can make many mistakes in schematics, in component selection, but I don't want us to make more mistakes in on PCB and from mechanical point of view, because slight shift, slight offset of 1.5 millimeter of mounting hole means that your board sometimes must be scrapped and you need another revision. And I think we need to avoid such a wasting.
Yeah. So I guess probably one of the key benefits of Benny devices is it accelerates your development time, and you can be sure that what you get is going to fit in the enclosure. So that's really good stuff. Um, Unless you've got anything more to talk about that you want to talk about with Benny devices, it'd be cool to just ask you some general questions.
Yeah, go ahead.
Cool. So obviously this talk has been all about making sure the mechanical design fits with the electronics part of the design. So and you've got, did you say 20 years experience?
Yeah, almost 20
Yeah.
years. Yeah.
So um, for our audience out there, what would you say are the top things you've learned? Let's say top three things you've learned um, in the process of doing your work for, in general as a design engineer, and also in building Benny Devices as a company to solve the one big issue that is the kind of the distance between electronics and mechanical design.
hmm hmm Yeah, a good question. I think I I realized that there are really two worlds, like mechanical world and electrical world, electric engineers world and mechanical engineers world, and sometimes there is no overlap between them. So yeah, we need to talk. We need to. I think uh, in every development team we need mechanical engineer, because yeah, hardware design templates at many devices are cool, but it don't solve any development issues. So we need to involve mechanical engineer to the team, as well as a skilled electrical engineer, and
Mm.
they need to speak from the very beginning of the design process, because you have to keep in mind the certification, yeah, the component selection, the enclosure selection, the material of the enclosure selection, because once you need your device to be certified in the EU or even US or worldwide, you need flame retardant materials for the enclosure. You need yeah, good and sufficient insulation distances and
Oh yes, of
everything.
course, yeah.
Yeah, so it means that you have to be on the same boat with every team member, and not to put like unpleasant things later. Yeah, you need to talk and you need to cooperate. So I recommend that every development team has a mechanical engineer, or how to say, not only mechanical engineer, it can be like designer or constructor. I don't know what's the names of the positions, but yeah,
Yeah, that's fair enough. Yeah.
engineer who knows to work with 3D modeling and everything. So this is the things number one I've learned on the process. Second thing, I don't know. We have to cooperate. We have to talk. We have to be maximally open. Yeah, every time I start a new project with a customer, I want to be maximally open because the customer must know everything what's happening in the process or in the development, and every single issue must be the customer must be informed about every single issue, because he is the decision maker, the primary decision maker. Yeah. I, as a freelancing design engineer, and as a freelancer, as a contractor, I need to like I'm not a partner of the customer. I'm the servant of the customer. I need to
Okay.
make him happy, and every time I like keep any fact to myself and to hide anything, it's not good, and it's the certain way to hell. So be honest, be open every time. Yeah. And the third thing, I don't know. Probably, yeah, probably. Every time you want to start with anything, just start. Don't look for a perfect time. Don't look for a perfect tool. Don't look for anything. Just start. You have everything you need. You have your brain. You have your hands. You can have a sheet of paper and pen. It's everything you always need. Some engineers struggle with looking for a tool, like for planning, for drawing, for everything. Yeah, even in these days, there are AI in every tool, and sometimes you are lost in the loop of looking for the perfect tool and testing and verifying and retesting and searching for it. Honestly, I've been using the ChatGPT since the release, because it is a big helper. Like it's a yeah. I don't know how many hours the tool has saved me along the way. Like at least tens, probably hundreds, because I I use it as a independent consultant. Yeah.
Okay.
For example, I study something in the datasheet and in the application note, but I'm not sure. There is something I don't understand, so I drop a question to the ChatGPT, and from the answer, I can see if it confirms my thoughts and my ideas, it's good. If it's something opposite, I think I say to myself, "Aha, you need to rethink. You need to restudy, because there is something missing." So it saved me a lot of time. I I used to offer the programming services in the past. I stopped like 2 years ago, almost 2 years ago. But for a particular project, I say, okay, I will. And yeah, in the like 1.5 year ago, I say, yeah, I would program it for you, but like a small program, not anything big. And I used ChatGPT for independent helper with coding, and it was really cool. And yeah, I recommend using every engineer to such a tool. It can be Bart, it can be ChatGPT, it can be anything different, but the ChatGPT is great for engineering work.
Cool. I just thought of one more question I want to ask, and then we'll kind of sign off, because this has been a really good chat. So, obviously you're now straddling the line between electronics engineering and mechanical engineering. So in terms of software tools, what would you say is the easiest software tool or software tools for an electronics design engineer to start using if they need to start doing more mechanical design? I think that would be a really useful answer.
So from my perspective,
Mhm.
you mean what the mechanical CAD tool I recommend to the audience, or
So, for instance, so funnily enough, I've worked with AutoCAD and SolidWorks from the mechanical design side, um, but so say if you were a design engineer and you're using like Altium and stuff like that, which of the mechanical tools do you think would be the easiest to start using?
Yeah. So I'm using the KiCad for the electrical engineering,
Okay.
capture, for the electrical stuff, and I can recommend the FreeCAD. It's a free as well as the KiCad, so there is no initial, like, no subscription, no
Nice.
fee, no anything, and I'm bad at when using the FreeCAD, very bad. But I use it mainly for verification of the enclosures. Sometimes verification of the hardware design templates. Mainly for preparing the models for components, because I maintain my own component library. Yeah,
Yeah.
symbols, footprints, and uh, every footprint in my library has to have the 3D model, because some a few, not a few, many customers wants the 3D model of the PCB for their mechanical engineering team.
Yeah.
So I need model of every component there. So I use the FreeCAD for
Okay.
creating
Cool.
components. I struggle with addressing on the website and founding. So FreeCAD. To be more precise, I'm on a Mac, so there is
Okay.
not so many options. I can virtualize Windows, and I do, but KiCad and FreeCAD are the first choice for me.
Cool. Okay, good to know. Well, this has been a really cool chat, Petter, and it's always good to talk to you. I love seeing your posts on LinkedIn. So anyone watching this, highly recommend you go and follow Petter and Benny Devices on LinkedIn. Do you have any other social medias you use?
No, only LinkedIn.
Okay,
Only
cool.
LinkedIn. Nothing more, because I think it's the more professional network. So yeah,
Yeah,
let's
definitely.
find me on a LinkedIn, and probably Iman will put a link to my profile below the
Oh,
video.
definitely. Thanks for tuning in, everyone, and I hope you learned something about uh, hardware design. And clearly, um, I mean, I've taken away from this that there's definitely a divide between electronics engineering and hardware and mechanical engineering. I never really realized that because I came from a mechanical engineering background and then started in electronics. But yeah, thank you, Petter. And I'm sure we'll do a little write-up on Benny Devices for the ipXchange site. But yeah, I'm sure, let us know when you have 100 designs and we can follow up and see what other stuff we learned.
Yeah, thank you. I will let you know. Thank you for having me again, and have a nice day.
Yeah, and you. Thank you. So it's always good to have a chat with Petter. I've known him very early on in my ipXchange days, and he's become a really good, I guess, LinkedIn friend ever since before Electronica. But when we met at Electronica, that definitely sparked something. He actually has the red version of the ipXchange t-shirt. I think the work he's doing with Benny Devices is just invaluable. It actually came as a surprise to me how much of a disconnect there is between mechanical design engineers and electronics design engineers, because I've always kind of straddled the line between both, probably more on the mechanical side, to be honest. Finishing a beautiful design and then finding out that you've got a screw going through your PCB, or it doesn't fit, or the connectors collide with each other, that's something you don't need. So check out Benny Devices. Their website is benny-devices.eu. Peta's got loads of hardware templates there, which for the price of a couple of cups of coffee can save you probably weeks, maybe months of redoing your design because you just didn't have the right PCB shape and clearances for your favorite enclosures. I've done a write-up of kind of what Benny Devices does on the ipXchange website, just because if someone comes along and they see that, it's going to be useful to them. But basically, we'll send you straight to Peta. And if you're a enclosure manufacturer and want to connect with Peta and have more people using your designs because they know their PCBs will fit, fill out a form on our website and we'll put you in touch with Benny Devices, aka Peta Dvorak. Your stuff will be supported by a lot more design engineers.